everyone and welcome back to Study Room. In the previous video, I taught you some basic concepts of exponents and powers, and we even tried solving some numerical problems to test the concept that we grasped. In today's video, I'll be teaching you the main part of exponent, that is laws of exponents, and then we'll be solving some interesting numerical problems to check our concepts. So let's get started. Now I'll be teaching you the law of exponents. The first law of exponent deals with the exponents with like bases. So if we have two exponents with like bases and they are multiplied with each other, then their powers will be added. So this is the first law of exponent, that when bases are same and they are multiplied with each other, their respective powers will be added. Let us see over here. We have a non-zero integer, that is a. So we have a non-zero integer a and it is raised to the power of m, where m is also any integer. And then again we have another exponent that is having base as a. It is a non-zero integer and its power is n, which is again any integer. So we can say that these two integers, that is a to the power m and a to the power of n, they are exponent with like bases. Now over here they are multiplied with each other. So when a to the power m is multiplied with a to the power n, we will get a to the power of m plus n. Over here there is a mistake. It will not be mn, it will be a to the power of m plus n. So the concept is when bases will be same, their powers will be added. Now this is the case of multiplication, that when bases are same and they are multiplied, their powers will be added. Now what will happen if we have exponent with like bases and they are divided? That means a to the power of m is divided with a to the power m. So these two exponents have like bases and they are divided. So in case of division, we have a to the power of m minus n. This means that when they are divided, their powers will be subtracted. So we learned two laws of exponent, that is, when exponents are having like bases and they are multiplied with each other, their powers will be added. Similarly, when we have exponents with like bases and they are divided by each other, then their powers will be subtracted. So over here we have an example, that is 2 square multiplied with 2 to the power of 5. So we can observe that the bases are same. In both the cases, the base is 2. So when bases are same and they are multiplied, powers will be added. So we'll have 2 to the power of 2 plus 5, that gives us 2 to the power of 7. Now, what if we have division? So, if we have 3 to the power 7, that is divided with 3 to the power of 4. The bases are same and they are divided, so their powers will be subtracted. So, ultimately we'll have 3 to the power of 7 minus 4, that is 3 to the power 3. So, the answer is 3 cubed. Now I'll be teaching you power of a power. Interesting? Yes. So power of a power is basically when we have an exponent. Like we have 2 to the power of 2, that is 2 square. And then this entire exponent is raised to another power, let's say 4. So then what will happen? What happens is that if an exponent is raised to another power, then both the powers gets multiplied. So this means that we will result in 2 to the power of 4 multiplied with 2, that is 8. So if we have a as a non-zero integer and m is the power of a, and then again this entire exponent is raised to another power, that is n, then these two powers m and n gets multiplied to each other and we will result in a to the power of mn. Again, another important thing is that whenever the power of an exponent is 0, that means it will result in 1, be it any number. Even if we have 100 to the power of 0, the answer will be 1. So here we have another law, that is if an exponent is there, so a to the power of 0, we get 1 as the answer. Any number which is raised to the power of 0 is always 1. Now let us try doing some example on these law that we learned just now. So we have 4 to the power of 3 and this entire thing is raised to another power. That's why I told power of a power. It is raised to another power 5. So what will happen? Both the powers will be getting multiplied. So 3 multiplied with 5 gives us 15. So our answer will be 4 to the power of 15. Now if we have 2 to the power of 0, any number raised to the power of 0 gives us 1. So the answer will be 1 in this case. Now I'll be teaching you how to multiply or divide, or what happens when we multiply or divide exponent with unlike bases but like power. That means exponent having different bases but same power. So if we have an exponent a to the power of m and we have b to the power m and they are multiplied to each other. So over here we see that the bases are different. Here the base is a and here the base is b. But the power to which the bases are raised are same. In both the cases we have m. So when the powers are same but the bases are different and they are multiplied with each other, then what happens is that the bases gets multiplied and we take the common power. So the answer will be ab to the power of m. That means a and b gets multiplied with each other and we take a common power, that is m. Now what happens in the case of division? In the case of division also, if we have a to the power of m and it is divided by b to the power of m. So we will divide these two bases, that is a by b, and take m as the common power. So the answer will be a divided by b and we will take m as the common power. So this was another law of exponent. Let us try doing some examples. Over here we have 2 to the power 5 multiplied with 3 to the power 5. So this is an example of exponents with unlike bases and same power. So what we will do? We will multiply the bases. That is, we will multiply 2 with 3. This gives us 6. 6 to the power of 5 will be our answer. Again, if we have 3 cube divided by 2 cube. We have unlike bases. They are divided and their powers are same. We have 3 cube and it is divided with 2 cube. So what we'll do is we will divide the bases, that is 3 divided by 2, and take 3 as the common power. We know 2 1 times, 2 3 times gives us 6. So ultimately our answer will be 3 cube. Now I have taught you a few laws of exponent. Let us use those laws and try finding out the value of the given exponent. So here we have 2 raised to the power 3, that is 2 cube, multiplied with 2 square. So here we will be using the very first law of exponent, that is, if the bases are same and they are multiplied, their powers will be added. So we will have 2 to the power of 3 plus 2, that gives us 2 to the power of 5. And this means 2 is multiplied with itself 5 times and that gives 32. Now over here we have, again the bases are same, but this time they are divided. So in case of division, the powers are subtracted. So we'll have 2 to the power of 3 minus 2, which gives us 2 to the power of 1, that is equal to 2. Now let's try solving some more problems. So over here we have minus 4 raised to the power 5 multiplied with minus 4 raised to the power 10. So again we'll be using the first law of exponent, that is, bases are same and they are multiplied, so their powers will be added. So we have the base as minus 4 and the powers will be added. So we'll add 5 with minus 10. So we get minus 4 to the power of, now 5 minus 10 gives us minus of 5. So we are left with 1 by minus 4 to the power of 5. Because I have taught you that a to the power of minus m is equal to 1 by a to the power of m. So here the sign of the exponent was negative, so I took it in the denominator and it became positive. Now let's try solving the next question. Here we have 2 to the power 5 divided by 2 to the power minus 6. So this is the second law of exponent, that when bases are same and they are divided. So now what happens in this case? The powers get subtracted. So the answer will be 2 to the power of, the powers will be subtracted. So I'll subtract 5 minus of minus 6. So this gives us 2 to the power of 5. Minus into minus becomes plus, plus 6. So ultimately our answer is 2 to the power of 11. Now we have a question over here that express 4 to the power minus 3 as a power with the base 2. That means we have to express this exponent in such a form such that its base is 2. Now 4 to the power minus 3 can be written as, this 4 can be written as, it can be written as 2 multiplied with 2. And here the power will be same, that is minus of 3. Now when 2 is multiplied with itself 2 times, it can be written as 2 square and then the whole power is minus 3. Now do you remember I taught you one thing? Powers to a power or powers of a power. Yes. So in that case, what happens? Both the powers gets multiplied. So we will have 2 and the power will be 2 multiplied with minus of 3. So our answer will be 2 to the power of minus of 6, because when 2 is multiplied with minus 3, it gives minus 6. So here we have an exponent with base 2. You can even further simplify this exponent and write it as 1 by 2 to the power of 6. Because I taught you a to the power of minus m is equal to 1 by a to the power of m. Over here we have another question where we have to simplify and then write the answer in exponent form. So the very first question is 2 to the power 5 divided by 2 to the power 8 whole to the power of 5 multiplied with 2 to the power of minus 5. Now here 2 to the power 5 is divided by 2 to the power 8. So bases are same and they are divided. So the powers will be subtracted. So we'll write 2 to the power of 5 minus 8 and then whole power of 5 multiplied with 2 to the power of minus 5. Now we know one thing, that 5 minus 8 is minus of 3. So it will give us 2 to the power of minus 3 to the power of 5 multiplied with 2 to the power of minus 5. Now 2 to the power of minus 3 whole to the power of 5. Powers of power. So minus 3 will be multiplied with 5 to give us minus of 15. So the answer will be 2 to the power of minus 15 and then it will be multiplied with 2 to the power of minus 5. Now here we have to use the first law of exponent, that was when bases are same and they are multiplied, powers will be added. So minus 15 will be added to minus 5. So we have 2 to the power minus 15 added with minus of 5. So this ultimately gives us 2 to the power of, now minus 15 minus 5 gives us minus 20. This can be written as 1 by 2 to the power of 20. Why? Because we know that a to the power minus m is equal to 1 by a to the power m. So this is the final answer for the first question given to us. The next question that we have with us is minus 3 to the power 4 is multiplied with 3 to the power of minus 3. Now let me tell you one thing. Whenever we have a number whose sign is negative, that means we have a negative number and it is raised to some power. If the power is an even integer, here we have 4, 4 is an even integer, then that negative sign will disappear in the answer. For example, if we have minus 1 raised to the power of 2, this power is even. So this gives us plus 1, because minus 1 square means minus 1 multiplied with minus 1. So the minus into minus becomes plus. But if we have minus 1 cube, so what happens over here, when this power is an odd number, then this negative sign will retain. So here the answer will be minus 1. So in this problem that we have minus 3 to the power of 4. 4 is an even integer. So this minus sign will disappear and it will give us 3 to the power of 4. Why? Because 4 was an even integer. Had it been an odd integer, then the minus sign would have remained. So we can write this as multiplied with 3 to the power of minus 3. Now over here, we'll use the first law of exponents, that is when bases are same, then powers will be added. So 3 to the power of 4 plus minus 3. So this gives us 3 to the power of 1, because 4 minus 3 is equal to 1, and this is ultimately 3. So this is the final answer for this question. Now let us try solving some more numerical problems on exponents. So the problem given over here is 1 by 3 to the power of minus 2 minus 1 by 2 to the power of minus 3 divided by 1 by 4 to the power of minus 2. Now, as I taught you in the previous question, that whenever the power, that is the exponent, is having a negative sign, so we will take the reciprocal of the base in order to remove the negative sign. So here we have 1 by 3, we will take the reciprocal of 1 by 3, which is 3. So what will happen? The power has a negative sign, this negative sign will get removed. So it will be 3 square minus 1 by 2 to the power minus 3. Again we will take the reciprocal, so it will be 2 to the power of 3 divided by 1 by 4 to the power minus 2. Taking the reciprocal will make this minus sign disappear. So what we have is 3 square minus 2 cube divided by 4 square. 3 square means 3 multiplied by 3, that gives us 9 minus 2 cube means 2 multiplied with 2 multiplied with 2, that is 8, divided by 4 square is 4 multiplied with 4, that is 16. So ultimately we have 1 divided by 16, which is equal to 1 by 16. The next problem given to us is 5 by 8 to the power of minus 7 multiplied with 8 by 5 to the power of minus 5. So here what we will do is, we will take the reciprocal of this base in order to eliminate this minus sign. So we have 8 by 5 to the power of minus 7 multiplied with 8 by 5 to the power, this minus sign will become positive because we have taken the reciprocal of the base. So it is 8 by 5 to the power 7 multiplied with 8 by 5 to the power of minus 5. So now we'll use the first law of exponent, that is, when bases are same, their powers will be added. So we have 8 by 5 to the power of 7 minus 5, which is equal to 2. So we have 8 by 5 to the power of 2. Now we can take this power separately in the numerator and in the denominator. So this gives us 8 square divided by 5 square. 8 square means 8 multiplied with 8, that is 64, and 5 square means 5 multiplied by 5, that is 25. So this is our final answer, that is 64 by 25.